We are going to take a look at trigonometric ratios. Some of this will be review, and then after reviewing the ratios of a right triangle, we will move it into the unit circle. All right, your basic ratio definitions are as follows. We have an angle theta in a right triangle, and we call this the reference angle. A hypotenuse, if you'll notice, for our reference angle, that would actually be the terminal angle. The opposite leg is opposite of your reference angle, and the adjacent leg is actually your initial ray, if we were on the Cartesian coordinate system, and it is adjacent to the reference angle. So remember that sine of theta is equal to opposite leg over hypotenuse, while cosine of theta is your adjacent leg over hypotenuse. And your tangent, theta, is the opposite leg over the adjacent leg. And you should have worked with these in math too. All right, so let's take a look here. Notice that for our terminal ray point, that it is on the circumference at some point called xy. Okay, and when we draw a right triangle from that, point down to the x-axis, we'll get a perpendicular bisector, and that the distance from the point down to the x-axis would be considered y, and then the distance of the adjacent leg along the x-axis is considered x. So when we look at sine, we can say it's y over r. So the hypotenuse is the radius of the circle. Okay, the cosine would be x over r. And then the tangent theta would be y over x. So there's our sine, our cosine, and our tangent, now written instead of opposite leg over hypotenuse, or adjacent leg over hypotenuse, or opposite leg over adjacent leg. We can now just say y over r, x over r, and y over x. Now, please notice what happens when we change our radius to 1. So again, we still have an opposite leg, that is y. We still have an adjacent leg for x, but now the radius is 1. And so the sine of theta is equal to y over 1, or just y. So whatever the y component is of the ordered pair, it is now the sine theta is equal to that y. And now the cosine theta is equal to x over 1, which is just equal to x. So now cosine, we can link it to x. And then the tangent is just your y over x value of the ordered pair. Okay, so notice the sine becomes y, the cosine becomes x, and your tangent theta is y over x. So this simplifies down compared to what you were doing with math 2. Okay, we're just going to take a quick look at the reciprocals. So if you're looking at the cosecant, which is 1 over the sine, notice how the radius is over y. Your secant is 1 over cosine, and again, the radius would be over x. And then the cotangent is equal to 1 over the tangent, so the reciprocal is x over y. It's just flipped. Okay, so just notice the inversion there for that. All right, we're going to take a look at our unit circle. We talked about pi over 6, pi over 4, and pi over 3 in our last ed puzzle. I would like you to notice this is a 30-degree triangle, okay? So when we have a right triangle and it is given the hypotenuse of 1, remember that using the Pythagorean theorem, we can figure out what the opposite side is and what the adjacent side is. This triangle over here is 45 degrees. And again, our hypotenuse is 1. And by using the Pythagorean theorem, we can figure out what our opposite and adjacent legs are worth. Okay? And we're going to use this in order to construct our unit circle. Please remember that the reference angle will always be less than 90 degrees. Okay? So in the second quadrant, when we start wanting to calculate reference angles, so we have a 5 pi over 6, and the blue would be the reference angle. Notice how the reference angle is going to come from your x-axis and meet the terminal angle, the terminal ray for your 5 pi over 6 angle. Okay? So it's going to be pi minus 5 pi over 6. We have to convert the pi into fraction form. So it's going to become 6 pi over 6. Okay, then that's just easy to subtract. And so this is just your pi over 6 or 30 degrees, and that would be your reference angle. Okay? All right, we'll take a look at what happens again in the third quadrant. Okay, now we have an angle. This is 5 pi over 4. It goes into the third quadrant. And notice how the reference angle comes back along that. And again, it has to come and touch the x-axis. So we'll have 5 pi over 4 minus the pi. We'll change to a fraction form of 4 pi over 4 and then do the subtraction. So that means that angle is pi over 4. Okay, let's take a look at what happens in the fourth quadrant. So we have an angle that goes into the fourth quadrant. Notice our blue section, that would be our reference angle. And instead of taking it from pi, we're going to take it from the 2 pi. So we'll have 2 pi minus the 5 pi over 3. So that means 2 pi is 6 pi over 3. And we'll subtract the 5 pi over 3, and that equals pi over 3, which is 60 degrees. Okay, and that it would be considered your reference angle. So again, notice that the reference angles are always going to the nearest x-axis. Sometimes it's pi, and then sometimes it's 2 pi, where you're at. Notice the reference angle would be the angle in the first quadrant. All right, now that we have taken that little detour about our reference angles, let's come back and take a look at what happens here on our unit circle with the sine and the cosine and the tangent. Notice that the sine is equal to y, the cosine is equal to x, and the tangent is equal to y over x. Notice your pi over 6, again, this is 30 degrees. And then your pi over 3 is 60 degrees. But notice that 30 degrees and 60 degrees, these triangles basically all have the same numbers, right? They're just reorganized a little bit. Notice that the 1/2 is always the shorter side, while the square root of 3 over 2 is always the longer side. And then, of course, we're dealing with a radius of 1 or a hypotenuse of 1. So when we go to find our x and y coordinates for, for the 30 degrees for the pi over 6, notice that your x is your adjacent and that your y is your opposite leg, okay? Let's move, and so it says x is equal to the square root over 3 and y is equal to 1/2. If we move into, or Yeah. And notice that we then place them over here in the chart, and notice that the tangent, remember the tangent would have been the 1/2 over the square root of 3 over 2. We would just flip that, and we would get 2 over the square root of 3. Notice how the 2's cancel, and this would have been 1 over the square root of 3, but we can't have the radical in the bottom of a fraction, so we have to multiply the top and bottom by the square root of 3, and that's how we get the tangent. Okay, let's take a look at the 60-degree one. Notice that now the cosine is the short side of this triangle because that would be right here. So x would be equal to 1/2, while the y would become the long side. And so the y would be equal to the sine, or y would be equal to the square root of 3 over 2. Again, um, when we find the tangent, we would just get the square root of 3. The 2's would cancel, and you would have the square root of 3. As we continue to move around into the second quadrant, notice that we still have the same numbers, okay? It's just now in the second quadrant, our x is equal to a negative, okay? So notice how your x becomes a negative. And if we move down to 5 pi over 6, again, it's the same as what was in the first quadrant. It's just the x term is going to become negative. As we continue going around uh, the unit circle, notice in the third quadrant, both the x and the y's are negative. But again, it's the same numbers in the same space. Negative square root of 3 over 2, negative 1/2. Okay, as we move to the 60-degree angle, now we have negative 1/2, negative square root of 3 over 2. So again, the numbers are repeating. You just need to remember that for the 60 degrees, your x value is always going to be 1/2. The y value is always going to be square root of 3 over 2. But now in the fourth quadrant, it is the y that is negative. All right, and then we come all the way around and almost all the way to 2 pi, but 11 pi over 6. And again, for our 30-degree one, we have the square root of 3 over 2 for your x, and the negative 1/2 is your y value. Okay. All right, let's look at our 45-degree angle, which is pi over 4. So this is our 45-degree angle. Okay. And again, notice on the triangle that both of our side, whether it's opposite over hypotenuse or adjacent over the hypotenuse, they're both the same, and that's the square root of 2 over 2, okay? So as this moves around, it's always for your 45-degree angle or pi over 4 angle, always the square root of 2 over 2 for both the x and the y. The only thing that changes is which one has the negative, or if both of them have the negative. Okay, so there we are for 5 pi over 4. Both of them are negative because that's the third quadrant, and everything's negative in the third quadrant. And then for the fourth quadrant, just the y is negative for 7 pi over 4. For the tangent is always 1 for 45 degrees. Okay. All right. So here we come, and we're going to take a look at what happens when we are at 0 or 2 pi, pi over 2, pi, and 3 pi over 2. Notice that again, here's your x and here's your y. And remember that the tangent is always the sine over the cosine. So in this case, for the first one, your tangent is 0. okay, because it's 0 divided by 1. All right. Then for the 45 degrees, or for the 90 degrees, the sine is 1, and then the cosine is 0. And again, we cannot divide by 0, so the tangent is undefined. Then we move around to pi, and in this case, the sine is 0, the cosine is -1, and so our tangent again is 0. For 3 pi over 2, we have -1 and 0, and again, that is undefined because you cannot divide by 0. And then for 2 pi, it's the same as 0. So this is what, when you fill out all the tables, this is what the unit circle starts to look like under radian measures, and this is what it would look like with degree measures. And when you put that together, you have the unit circle, okay? So this is a circle with a radius of 1, and every point P, X, Y on the circle, unit circle, so R has a unit of 1, and therefore an angle theta is in the standard position. So your sine of theta is equal to Y, the cosine of theta is equal to X, and then your tangent theta would be Y over X. Thank you for your participation. The end.